Welcome, everybody. Tonight we're working on Unit 13. Our topic for the evening is using natural language processing for more than just one language, actually for multiple languages. Just a little bit of a recap as to where we've been, right? So we've spent this whole semester learning about natural language processing, arguably one of the more important areas of artificial intelligence these days, because this is really the type of technology we truly associate with what we think the AI revolution is that's happening right now. We've looked at how to design the pipelines and do the modeling. So like where your data comes from, how the models are built, what kind of models are being used, what their applications are. And then we see like kind of like the primary tool of NLP really are these, kind of like, these chat windows that's how we're interfacing with these tools. And I know several of us here do subscribe, right, to maybe one AI engine or another. And I'm really curious, as before I dig into materials, how many of you use those AI agents in audio mode where you click the microphone and just talk to it? Does anybody do that? All right. And okay, Chris, thank you for sharing. Laura, Susan, okay, thank you. I think that's really kind of an interesting approach. And normally I would kind of get into a whole discussion about what do you think about that, right? But I want to get through the materials here primarily. Now, the whole point with chatbots is, we're moving into this really interesting era right now because I've been reading a whole bunch of articles where Google has been very, very recently, by the way, making some significant inroads with their AI agents and models and getting ready to like publicly release them for consumption, to the point where I'm not sure if there's going to be a cost involved, but if they like put these tools out for free, I think it's going to be a really exciting era because, Google right now, Gemini at first wasn't one of the go-to ones that we would use. We'd always go to ChatGPT first, and then we'd maybe go to Claude and a couple of others. But Gemini's made a lot of inroads. And in some ways, I think it's starting to get better than some of the others. I still have some issues with it, whatever. But if Google releases their core language tools to the public, and you can go in and make your own chat bot without really even trying and start building your own stuff on top of it, how revolutionary could that possibly be, in terms of the work that we do? And I think it's really kind of an interesting thing. We already have plenty of tools that sort of do it on that level, and we do get an enhanced version, by the way, when we work on our Google platforms, right? Because Gateway is a Google shop, as we call it. All right, so the agenda for this week is to look at natural language techniques for English, mostly as a basis of comparison for when we switch to other languages. We do have this naive assumption, right? And I say this as, an American, born and raised here, right? Even though English wasn't my first language, that, oh, well, we all speak English. I really don't need any other languages. And you know what? Why do the other languages even matter? Right? And that's a very ethnocentric, viewpoint, if you think about it, because we're certainly not a majority of the planet population, but we make this assumption that the whole rest of the planet has to speak our language. And ironically, English is the primary language for learning, commerce, diplomacy, et cetera, et cetera. Pretty much everybody has to learn it, to the point where even in the European Union, English has become kind of almost an official language across all the countries of the European Union. And anybody that goes to school there for the last 25, 30 years, because they're part of the European Union, they're all forced to learn English. So if you ever, go overseas and you talk to anybody pretty much under 30 or 40, they pretty much speak English, right? And then the other aspect that I always throw at people, and we don't even think about this, is what what country on earth has the largest English speaking population? And I want you to ponder that for a second. Well, probably not England, because we probably have more people here in the US than England, right? And you can Google these facts, I'm sure. And certainly it's not going to be Canada, because Canada doesn't have as many people. And, I guess there's those Australians and New Zealand people as well. And what people ignore, though, is that there's India. And India's got like 1.3, 1.2 billion people. And one of their official languages is English. And they were, less than 100 years ago, they were a British colony. So they have actually many languages there. Hindi is their ethnic primary language, but most people there also speak English. So I think that's pretty astounding. So that's why, English, is kind of important. The other thing that makes English really important, at least in terms of the stuff we're learning, is that basically all coding languages are written in English also. And thank goodness, right? Could you imagine? And I always tell this to my students, you imagine like being, I don't know, Chinese, or pick an ethnicity, and you don't know English and you want to learn how to code. Well, guess what? Now you have to learn English first, just so you can learn how to code in that language. Really bizarre, right? And then you have to also work with the concepts, which are hard enough on their own. We're also going to look at some of the other primary languages on the planet, or at least ones that are important, or easy to focus on. And we're most notably going to look at Mandarin, Spanish, German, and French, right? And I would want to do just a really quick little poll here before I go past this slide. Is there anybody here who speaks any of those languages or knows those languages? All right, Susan, Laura, you can just throw it in the chat. What other languages do you speak, if I may ask? You don't have to unmute and have it recorded, I suppose. I'm more curious for, okay. Very cool. All right, so both of you, okay. Right, and that's, I mean, we're in the US, right? That's basically our second language here, even though it's not official. And Gateway is a Hispanic serving institution, by the way. Let's hope the government doesn't take that status away from us. Okay, Martin, some Spanish, some German. All right, very cool, right? Well, thank you guys for sharing. I appreciate that. All right, let's kind of start talking about this. We're kind of already in the flow of it a little bit. We do have kind of like this weird thought that when we speak, right, like our language, is a prominent one right now, because you could argue, the US might be, one of the world leaders, for sure. And our language and economy kind of dominates. Our military certainly dominates, right? And our culture also kind of propagates across the planet. And so we become very unaware of the rest of the planet. And one thing I think it's really valuable about learning other languages is it gives you a different perspective, for sure, right? And this little map that they have here, and you can make it bigger if you want, right? Because it's really hard to read the legend on it, where they show all the different countries and the primary languages spoken there, or language groupings is a better way to put it. Isn't it fascinating, though, that, like, with English, right? So the US and Canada are kind of one thing. Then we have all of Central and South America, which pretty much speak Spanish or Portuguese, right? And those are two different languages, but they're part of the same language family. And then some of those languages are spoken here as well. And you see how it like spreads across the planet, right? So they're lumping in French, Spanish, Portuguese, Italian, all in the same family. And I will tell you from speaking Greek that Greek is not far off from those languages. It just has a different alphabet, and yeah, that's kind of a weird one. But you notice, like, there's different groupings for sure, right? And then when you start to think about the fact that about half of the world population is right here, right? That's really kind of astounding, actually, when you start to think about it. And they have the bullet here that there's currently more than 7,000 languages being spoken worldwide. That's pretty intense, right? There's major language groupings, and look at like the numbers on these. So, I guess, if you came from outer space and you visited Earth and you got this piece of information, like what language would you start to speak to somebody, right? If you landed on planet Earth, you go, oh, okay, well, I guess we better learn Mandarin because most of the people speak that, right? And then look, like, I think it's really interesting that it's only 379 million native speakers of English. So I know there's more than that that speak it, but native implying that that's the language you were born to speak. So you were born in England, or you were born in the US, or Australia, or Canada, and that's like the Queen's English, and that's what we're learning, right? Um, and what's the population of the US? That's kind of an interesting question in itself. It's like 330 million. So like we're most of that. Weird, very weird. But look at these other primary ones. Hindi, that's really big. Arabic, Bengali, Portuguese. So really important languages. And we might even know people that speak these languages, and I think that's really pretty fascinating. They have this little activity here, and I'm going to see if this link will fire up. Let's see what happens here. All right, there we go. And what they wanted us to do in here is search for the languages Mandarin, Spanish, and French and see their geographical distribution. So let's put in French, and I hope I'm putting it in the right search area here. Apparently that is not correct. All right, yeah, this is not working in the way that I'm hoping, right? And this is part of the problem with some of these online tools they want us to use. And what I'm gathering, I'm wondering if this is fully loading. So I might try a different browser here. Let me do that. I'll bring up Firefox. When Chrome misbehaves, folks, I usually go to Firefox as kind of my backup. So let's try that. Any of you use Firefox as your primary browser? Yeah, I'm just not getting it to work, and I'm not really sure what the issue is. I'll tell you what, we can come back to this, but the point of it really is to see what the language distribution around the planet. And this is what the map is supposed to look like, right? So like you're supposed to be able to type in Spanish, but if you guys notice, like these layers here, that little panel wasn't coming up for me. So I'm not sure if the website needs a little bit of attention. That might be possible. Um, I think it's pretty fascinating though when you start to do this, right? Like, for example, I mean, we do have an image here that we can look at. So somebody typed in Spanish, and look at the distribution of Spanish around the planet. A lot of people speak it, right? Not just in Central and South America or in Spain, right? Obviously, but all around the planet is a very common language. And any of you that have ever traveled, like, and what floored me is like the very first time I went to California back in the 80s as a young man, and I walked into a McDonald's and I looked at the menu and it was all in Spanish. And the people really at the register didn't even speak English. And I'm like, wait, this is Los Angeles, right? Am I like in a different country? It was very weird. Um, but it's not really that abnormal, right? And you know what? When I try my hardest and I hear Spanish enough, I can kind of tune into it a little bit, and I think that's pretty interesting. Um, Now, NLP, right now, I want you to think about this. With all the stuff that we've learned about language processing, like how we do it. Can you imagine now, like if you want to apply all those techniques to different languages, and if you know English and you know a different language, like, and this is true in Greek as much as it is in, let's say, Spanish. In English, I might say, may I please have a hamburger, right? And then in Greek, I would flip the words into a different order to say the same thing because that's just how the verbs and the nouns work together, right? But we're still saying the same thing, right? But that's got to be processed in a different way than it would be in English. And therefore, like if I use a different language, for example, we might have different stop words, right? And we might have different pronouns, or maybe there's no pronouns, right? Maybe that's wrapped into the verb or into the noun. So we're going to start looking at all these different language approaches. And the first step, usually when we're working with NLP, is we do have libraries that can detect what language you're speaking. Now, very interestingly, and I don't know how many of you guys have ever played with this, but have you ever seen like the Google Translate tool that's right in the web browser, right? Or if you have a phone, download that app. I've had experience where I've seen people who are traveling to the US in an airport and they have their translation app up and they talk to it and they're like, blah, 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 blah. And then they hold it up to the person. Where's the bathroom? I need to go, that type of thing. And I think it's really amazing that we're at that point. And then, okay, I think this is an interesting one, bullet number 2, because my friends would always poke fun at me about this. Like I would go talk to my parents or my grandparents who mostly spoke Greek, and they would say like, yeah, I don't know what you're talking about, but you obviously you wanted a cheeseburger, right? Because I'd be like, blah, 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 Greek, all in Greek, and then cheeseburger, blah, 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 Pepsi, 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 that kind of thing. And so I would mix English and Greek together because, hey, we're in the United States and I'm talking about American things, and there's no Greek word for cheeseburger, and there's no Greek word for Pepsi, right? How do you say cheeseburger in Greek? Cheeseburger. You put an accent on it and you say it, right? It's the same word, right? So I think that's pretty interesting. All right. So once you pick out the different languages, even if what's being spoken or written is a mix of those languages, and that happens, right? Then we can start to apply all the other standard techniques for NLP. So language detection comes first, right? And basically, we start to, identify it much the same way that we do as human beings. We use certain tools to detect languages. Like, how do I know that somebody is speaking a given language? Because I kind of know, like, for example, I think I kind of know what German sounds like. And I think I know what French sounds like. And I think I know what Spanish sounds like and Italian, right? There's certain expressions and the way the words are put together that help you identify it. There is a library in Python called Polyglot that is designed to basically do exactly that, just to simply identify the languages. That word does not happen accidentally. It's not an invented word by some Python programmer. It actually is a word that refers to somebody that can speak many languages. The one little tidbit I'll throw at you is, many years back, my dad worked for a guy doing import export, right? That was his business basically. And the guy that he worked for knew how to speak about a dozen languages fluently. And he learned all of those languages by virtue of having been basically lived through World War II and being moved from place to place and being forced to learn the new language or not survive, right? And he learned most of those while he was a child. And that's one of the little tips that they give people is like, if you're going to learn multiple languages, do it when you're a kid, because then it's really easy, right? You don't think about it twice. But this is also an open source Python library, right? And I want you to notice open source, what that means, right? Is it's free for the taking. It's just out there. You don't have to pay for it. There's no, fee for it, and anybody can use it to help analyze their applications. Notice that it does tokenization, language detection, part of speech tagging, so like noun, verb, pronoun, whatever, and transliteration in more than 50 languages. Very impressive, right? So whoever worked on that tool, and truly when we do open source software, it's usually multiple authors working on something. All right. We know uh, from this slide here that this is in Arabic, but let me ask, how many of you, like if you saw that script on the screen, how many of you would instantaneously recognize it as Arabic? You can do a show of hands. All right, Jared, Laura. Yeah, I recognize it too. All right, Susan, very good. What, and I'm going to ask you like a weird question here. How is Arabic different than English? Do they use an alphabet? Well, the answer is yes, they do use an alphabet, but there's still a significant difference. What is significantly different about how we write English and how Arabic is written? Does anybody know that answer? And I see Laura's typing something there. Yes, thank you, Chris. Correct, right? And I think Laura, that's where you were going, right? It's right to left. So that's really weird. So our eyes in English, right? We start up at the top left, move to the right, then we go down, right? And I'm trying not to mess up my slide here, but yeah, uh, top to bottom, left to right. Arabic, Hebrew. Can you anybody name a different language that goes right to left, backwards, basically for us? All right. Is anybody into manga, like those Chinese anime, like comic books? Those are all backwards too. Yeah, the Japanese do it that way too. So a lot of Oriental cultures also do that. So who's to say that left to right is the correct way, right? It's all in how you learn. So if you're going right to left, we pick up a book and we flip the cover this way, and a right to left world, they go the other way. Yeah. No, it's not backwards. We're the ones that are backwards, right? So imagine like the mind bender it is if you learn a language that goes one direction and then you got to learn a language going the other direction, right? And now you have to write a piece of software that does it. Well, the software handles it a little bit more elegantly because we can still load the characters into a program and we just tell Python to basically flip the indexes of the characters and work from the other direction. It's not really a big deal, right? When we do it with code. Um, Now, the Polyglot does have a detect tool, right? So you would pull in the detector, you would give it the text in whatever language it is, and then you run and it would just tell you what language it is. So that these are the commands for doing it. Very simplistic. Um, and it says that it takes the detector object takes a string from the language as input, assuming it comes in as a string, and the language can be printed with the language property. The output is Arabic with 99% surety. So you do get the language and how certain it is that it's that language. Right? Are there languages that are similar to each other? Oh, you bet. Yeah, there's a lot of them that truly are. Um, if there's a mixture of languages, it gets a little bit weird, right? And it can still handle it, and I'm very impressed by this feature. Now, nobody here speaks Mandarin or any Oriental languages. I'm just really curious, right? I have a couple of friends who are Japanese, so I know from talking with them that they have both a pictorial language like the Chinese do, right, which is the characters you see here on the screen, and they also use a script or like sort of like an alphabet called kanji, right? And that's how they kind of like use a keyboard, basically doing phonetic letters. But it always blew my mind that both the Chinese and Japanese languages had characters that represented entire words, right? So very different kind of approach than what we do. But interestingly, our character sets that are built into fonts, if you use the UTF-8 character sets, have most of the primary Chinese characters built into it. Wow, you know, or if you speak a language where they have accents and umlauts and squiggles and upside down question marks and exclamation points, that's all in there too. Even the weird Greek letters are in the UTF-8 character set. So what's kind of interesting here is that you can feed in a snippet of text like this. It'll identify the English and it will see the Chinese as well. And if I'm not mistaken, the way that Chinese reads, although they're a lot more flexible about their direction, I think Chinese reads top to bottom, then right to left. Talk about a different approach. Interesting, right? So we go left to right, then down. They go top to bottom and then left. Weird, right? Who's to say what's right or wrong? That's just how they. Well, he did it that way, so I'm doing it that way, right? That's kind of how language develops, right? So once again, we can feed in weird text like this and then run the detector, and you know, basically it will, give us the output that shows us what it is. And notice the kind of results that you might get. English code, and it says EN confidence. So this is one of the things that you're going to learn here is, what does EN mean? Well, that means English, duh, right? Probably, right? It would help if they put a G in there, then I'd get it even better. But they use these two-letter prefixes. And then with Chinese, I want you to notice that they have the ZH, and I'm not really sure what that stands for particularly, but it also has a postfix on it, because if and Americans don't know this, but in China, it's not just Mandarin, right? Chinese, they got, I don't know how many primary dialects, and they're kind of regional, right? And so they have sub dialects and weird things like that. But they're basically figuring out that 87% of this is English, and okay, not 87%, 87% and 5% confidence, right? Okay, so that's different than how much of it is one way or the other. That's how confident they are that it is that language, right? So, I mean, 5% confidence on the Chinese, that's not a very high confidence level, but I mean, that's the kind of results you're going to get. There's also this concept of what we call transliteration. And as you look at the definition here, I'm going to make that just a little bit bigger. That's much bigger, but there we go. I think that would help. It's a process of transferring a word from the alphabet of one language, right, to another. And I think this is really, really weird. Now, if you can imagine, if you are speaking a different language, that might, and you want to learn a different language, that might be lesson number one, right? Is to get, to learn the alphabet, right? And of course, we here as Americans get it drilled into our skulls. You go to kindergarten class, and it's pretty much about learning how to count to 20 and go through the alphabet and sing the alphabet song, right? All of that stuff. I had to go through the process when I was a youth. My parents forced me to go to Greek school, right? I was like a thing I had to do. Like 3 days a week, I'd be at the church at night, and they'd be teaching us how to speak. It wasn't bad enough I went to regular school. I had to go to Greek school as well, right? And you had to learn how the words were put together, how the alphabet worked, and Greek is one of those languages, at least traditional Greek, that has the accents and all the little decorations. But doing that comparison of like, okay, well, here's the letter J in one language, so English to Persian, or Arabic to English, or English to Japanese, and I want you to, like, there's some languages, okay, well, they're direct correlations, right? And then notice how, like, in Persian there's no H. Okay, weird. And then you get to Japanese, and then I take two letters and put them together to get this one. Wait, that's not quite the same. So wait, it takes two English letters to get one of your letters? Sure. I mean, that's how they do it, right? And then English to Hindi, and all the symbols are different. And can you imagine? All those languages not only have different like alphabets, but maybe they have weird fonts too that go with them, right? Like you take like your, I don't know, English language and turn on Comic Sans or something like that, and people don't recognize the letters. But I think it's the point of it, right? And this is what kind of where the translation starts, is identifying which letters match up. I think it's really interesting though that like many of the, let's say, Middle Eastern and European languages, which most of us are speaking, right, some form of, the alphabet concept really goes back thousands of years, right? Like the Greeks didn't invent, alpha, beta, gamma, etc., right? They borrowed it from the Phoenicians, who borrowed it from who knows who, but they had alphabets well before the Greeks used them. And then here we learn our ABCs, right? And I'll tell you, Greeks go alpha, beta, gamma, and I'm saying it like an American because in Greek we would say alpha, beta, gamma. That's how we say it, right? And gamma is like, it's like gyros, right? Like people say gyros, right? It's gyros. Yeah, so the G, gamma is basically a G, but we don't say it like a G, you know. And so trying to make all those comparisons, that's where it all starts, right? So right, and think about this. If you guys ever hear of the Rosetta Stone, right? They discovered in Egypt where they found ancient Greek, a language they knew, and then they were able to compare it to some other language, and then compare it to Egyptian hieroglyphs, and then finally decode the hieroglyphs and be able to read them. Right, and I think it's a fascinating language study. But if you don't have that, I mean, transliteration is kind of the approach. So some stuff matches up, some stuff does not, and that's just part of the process of of doing this. And I think I lost my slide here somewhere. There we go. All right. All right. So here's an example. In Hebrew, they say the Jewish winter holiday, Hanukkah, is spelled like this. Now, mind you, Hebrew is right to left also, right? Just like Arabic. And the English transliteration, right, where they try to compare the letters, is Hanukkah with an H or Hanukkah with a CH, because if you know anybody that's truly Jewish and speaks Hebrew and you hear them say the word Hanukkah, it's not exactly an H sound. It's like Hanukkah. It's like that. And Greeks make those kind of weird sounds too. Well, hey, check it out. We have a Greek example. The Latin transliteration of the Greek phrase Elleniki Demokratia. That's what it is in Greek. How do you like that? I can actually say it, right? Good thing I went to Greek school, right? But you notice how Greek has like these weird looking letters and the little accents in there. And and the joke always was, right? My teacher would do this in Greek school. You have to put the emphasis on the right syllable, to say the word correctly. Because in Greek, there are words where you put the emphasis on the wrong syllable and say it the wrong way, and it's a completely different word, and you go from like complimenting somebody to insulting all their family, so you got to be really careful what you accent, right? And notice, this translates to the Hellenic Republic when we change the words, but when we change the letters, this is really, and notice, Elliniki Demokratia. That's how you say it in Greek. So this is the phonetic, and this is the actual meaning, Hellenic Republic. And notice, in Greece, we call Greece Elada in Greece, right? What do we call? Everybody else calls it Greece. It has nothing to do with each other, right? Isn't that weird? Yeah. So these are the kind of issues that we deal with. So we can use the transliteration tool inside of Polyglot. So this is part of the other part of this tool, which is really cool. So it will transliterate. So in other words, it matches letters, but it also matches words. So you get the phonetic and you can get the word representation, which really makes sense. There is this downloader piece you have to throw in there too. So you have to like kind of pull it down depending on the language that you're working with. So that's part of the process of it. So you import the text, right? It transliterates, and notice that here there is a 2-letter abbreviation, and the AR, by the way, stands for Arabic, right? And that way it knows how to read it, right? Because remember, Arabic is backwards for us. So the software has to do that backwards as well. The interesting thing, and this is not, now that we're in the generative AI era, we have all these libraries that already do these tasks, and then we have intelligent agents that can kind of self-learn. Well, it kind of discovers new ways to do translation, and it uses these what we call sequence to sequence models, And they're calling it a new frontier, like it's some magical thing, I guess. Um, Now they're saying here that it says harnessing the power of these models. It says traditional transliteration methods have limitations in terms of accuracy and efficiency, and that one thing with the Greek that we looked at is a really good example of it. I think Gen AI, specifically sequence to sequence models, has revolutionized. Okay, by automating and improving its accuracy. So it does the transliteration part, but also the word part as well. The sequence to sequence model, also called the encoder decoder model, uses long short term memory. And it says for text generation from the training corpus. So it's using a higher level approach, basically, to do this. All right, I want to make sure I don't skip a slide here. So the encoder will read in the message, basically. So there's an encoder and decoder, and then it converts it all to vectors. That's the mechanics of it. And then it decodes it and gives you the thing in the other language. And this kind of leads to like what I was talking about before, like where like if you learn one language and you learn to say a phrase, you order your words a certain way, and then you say it in a different language, and all of a sudden, like, the subject is at the or the object is at the beginning of the sentence instead of the end of the sentence, that kind of thing. So the order sometimes changes. And then you also have like the masculine and feminine pronoun thing that you have to deal with, right? And it says it takes the input text in one script, processes it to extract meaningful features and patterns, and the encoding step captures the relevant information needed for accurate transliteration. So to get the right words, it's not just translating the letters, it's getting the right words. The vector, right? We know what vectors are, and the vectors are set to certain things. And then what we're really trying to do is get the essentials out of it. So there's still, like I said, we still have to process things like stop words and whatever. It doesn't matter what language it is. All languages have that. The decoder then takes the vectors and then generates words that match those vectors. And then it also learns, input and output sequences that map together. And this is, where we change the word order, basically. So that happens in the decoder part of this, right? The generative AI thing is really pretty big. And, this is really strange, right? But I've experimented with like the in-browser translators for various reasons, with different languages, but I've never tried it with generative AI. And that's really kind of an interesting experiment. It's not, I'm like kind of tasking myself in the back of my mind that one of these days I'm going to sit down and do that. I'm going to talk to like ChatGPT in Greek and see what happens, right? Right. And then ask it to respond in English or something. I think that's kind of interesting. All right, so they're looking at the advantages of this, like Gen AI can learn complicated patterns and transliteration nuances, making it accurate and dependable. The models can be trained on diverse language pairs and scripts across languages. Large-scale translation processes, saving time and labor. I think that would be pretty huge. After training, the model can transliterate vast amounts of text in real time or batch processing. And so this is, I think, probably one of the more interesting aspects, right? Because we've learned that all these AI models, it's all about the training that they get, right? Training is still happening, right? So we've spent all this time training, I don't know, ChatGPT, like the old versions on Wikipedia and news feeds, right? It's like, oh, wow, there's these other languages too. Well, I guess we better get busy, right? And that's kind of what's going on. All right. I think, why don't we do this? Let's take a break. This is a good spot for a break. Let's not make it too long. Like, let's go about 3-4 minutes, something like that. And then we'll come back and continue. So I'm going to mute, pause the recording here, and I'll see you in a few. All right, we're back from break and we're going to move forward in the slideshow here. Our next topic is to talk about what we call translation. And there are tools that are built to do that, by the way. So when we worked previously with TextBlob, and although granted kind of a brief exposure to it, um, it is another one of those libraries that's capable of doing some of these tasks. So excuse me. Um, for example, if you wanted to use this to do some translation, you can just bring TextBlob in, you can give it a phrase, and then you can tell it to translate to a certain language. This one would be Hindi, by the way. And you can, basically put in, he is a nice kid, and you get this back in Hindi, which apparently says the same thing. And I'm not really sure. I wonder if Hindi is a right to left language too. Maybe somebody can look that up. I'm not really sure about that one. Um, Pretty interesting. All right. So as we kind of keep moving forward here, we start to look at like how we can use this tool. And once again, once you know the 2-letter language codes, you can kind of translate to any language, right? And this is a very common tool to use, by the way, to do straight up translation. If you're wanting to look up language codes, you can just follow this link. I assume this one works. Oh, guess what? It doesn't. All right, so just be mindful of that. That's a dead link. Or at least that page that they're pointing you to is a dead link. Let me see if I can go to their parent site. Nope. All right, it looks like that website is down, by the way, so we should probably know. Yeah, unfortunately. I'm sure that if you look up TextBlob language codes, you would get a complete list. And I would speculate that the language codes often match up with the top level domains for the internet. There are a series of slides here, and I'm just going to tell you right now, I'm going to go through these pretty quickly. I'm not going to overly focus on these, but kind of my thinking is that they do demonstrate how to work with all of these individual languages here. And all of the languages have different, slightly different approaches because of, being different languages, but they do go through the process for each one of these. And so, now mind you, I'm going to go very quickly through these, without focusing on them too heavily. I'll try to hit on important topics. If you're doing NLP in Mandarin, you basically use Polyglot and this other one called Jieba. I think that's the correct way to say it. And it tells you what Jieba is for. It's for word segmentation, basically, and they do have a link here where you can look it up. We know what tokenization is, where we break sentences apart into words, paragraphs, whatever. But when we use this language, it's a little bit different, right? It's a very different type of language. It's a pictorial language. And I really don't know a lot about it, but I know generally speaking, it's a combination of pictorial words and sometimes a character language, and sometimes you have to combine 2 words together, or 2 symbols together to get a word. That's kind of a thing. And then they separate their sentences with these circles, right? And I mean, I'm assuming they're periods, right? And I think that Chinese is flexible enough that you can change its direction, by the way. But if I start to tokenize that sentence in Mandarin, this is kind of the output. So it's like kind of converting it to a Python list, right? And notice how there's still, quotes around it because it's still text as far as the coding language is concerned. And I'm noticing that a lot of it is, sometimes it's a single character, but sometimes it's multiple characters. So that's kind of interesting. I really don't know enough about the language to tell you for sure. But then they can take the sentences and kind of, break them down kind of the same way we break down English. And notice here, they can take a sentence like this, right? And they use the Jieba cut, and then it breaks it apart into words. And notice the slashes in there, which are doing the divisions. So this must be a sentence. That must be a sentence. Or maybe I'm not really sure how it works, folks. Right. But you can do that with that language. They also have ways to tag parts of speech, you know, the same way we have nouns and verbs and whatever. They have very much the same thing. And notice they have like a bunch of different breakdowns here, you know, from everything from identifying, you know, punctuation and prepositions and names and adverbs and verbs and adjectives and whatever. And notice how they kind of take the word and then give it a letter. So apparently this one here is a pronoun and this one here is a verb, right? And they give you a little chart even so you can figure it out. We've learned about sentiment analysis, so I don't feel like I need to kind of like lecture on this again. But you can also do sentiment analysis in other languages, right? You know, people in other languages have opinions too, right? Maybe they're even stronger than our own for all we know. In Mandarin, they have a library called Snownlp, NLP, that analyzes Mandarin sentiment. But it can also do other tasks. So this is where it gets kind of weird, right? Because some of these libraries, you know, many of them kind of have some overlapping features, right? It makes you wonder where they get the code from, because sometimes they borrow code from each other. But part of speech tagging, tokenization, et cetera, can all be done with Snow NLP as well. But sentiment analysis is really kind of its primary thing. So here they have a bunch of different Mandarin phrases that they're putting in there. And then the steps basically are as they tokenize the sentences, and then they pass each sentence to the Snow NLP thing to get a sentiment score. And here's an example of some sentiment outputs, for example, right? And basically they're all talking, it's like reviews for a product. You know, this product works well, or this product's not easy to use. This product is trash. Is this too expensive? Super trash. Is rubbish among trash? And I wonder what that really means, right? You know, it's like, yeah, whatever. But and generally speaking, when you know when these scores come out, right, with sentiment analysis, the higher the number, the more positive the sentiment. The lower the number, the more negative the sentiment, right? If you want to read up on this one is out on GitHub, right? And this is, you know, and we talked about GitHub as a place to put your code, but a lot of people publish a lot of open source stuff on GitHub, right? And that's kind of the repository where the stuff all resides. There's also one for Spanish speakers, right? And the sentiment analysis in this one can be used with this library, and it's called Sentiment Spanish, by the way. And you just basically call in that library, and then it analyzes it. And of course, remember, the higher the number, the more positive the sentiment. So we had a low number, maybe it's rubbish of trash, you know, in Spanish, whatever that means. They also have approaches for German, right? And by the way, Germany is like Greece, by the way. I mean, it's not that we don't call German people Germans and Greek people Greeks, right? But in Greece, it's Helada, or the Hellenic Republic. In Germany, it's Deutschland, right? And so their language code is DE, because that's what Deutschland starts with, is a DEU, etc. But this, so they have a specific TextBlob just for German, basically. Sentiment analysis, part of speech tagging, and tokenization are all possible. And notice that they're importing the German libraries. And I think it's very interesting, because if you do know anybody that speaks German, my wife speaks a little bit of it because she lived there for a little while, and I had lots of German friends growing up as a kid. And they're, you know, and if you guys don't know this, Milwaukee was at one time probably like 50% German speaking, right? And they'd call it the German Athens and whatever. And we used to have German radio stations and all that kind of stuff. But if you ever listen to people speak German, the way they put their sentences together is not too dissimilar from how English sentences are put together, right? So the order of the words is more like English than the order of the words in Greek or Spanish are like English. And I think that's really fascinating. and I don't know why this just popped in my head, but I do have part of my dad's extended family, an uncle, aunt, and a bunch of my cousins and their offspring all live in Germany. And every once in a while, I get to see my German cousin, and he's a really interesting character, by the way. But he's one of those guys that he'll switch from like Greek to English to German like in one sentence, and it's like, what did you just say? Tunkoff, here you go, do something like that for me, right? And I'm thinking of like Hogan's Heroes here. I apologize, very bad, very bad. All right, so you can. Oh, all right, so going back to this, right? You can run text blobs in there, so you can feed it a whole German sentence, and then Python will take this and tokenize it, so it'll break it into sentences, right? Notice how it does that. It makes a list, and then it creates a sentence thing, and then that passes it to the sentence thing, and it creates a word list out of it, so it can tokenize everything. And of course, German being not too far removed from like the Anglo-Saxon English, right? We have a lot of the same kind of things going on. And this is part of speech tagging, by the way. So all of these, so like whatever this word is, this indicates what kind of speech it is. Ist, that one I know. That one I think is just the word is, basically. So that's like a simple verb, right? Is I think what that says. So I think it's very interesting that it can do that, right? And it's just built to do that language, right? So pretty important thing. Parts of speech tagging here, once again, as an example. And then they can take words and kind of break them down. And they have this what they call pattern parser, and it gets really detailed basically on how it's tokenizing everything and identifying the words. You can also try to grab sentiment from it. So if you look at some of the things here that you can do, and once again, we're looking for high scores for positive, and then low scores for negative, and that can be extracted basically from the German. And if you are interested here in trying some of this, right, like, and once again, I don't know if these links are working or not. You can experiment with them, but you can use Spacey, which is one of those libraries that's out there, by the way, and you can drop in text and see what happens. I mean, especially I think interesting to get sentiment analysis out of it. They also have libraries for French, right? And TextBlob, once again, has a French library, basically, that it focuses on, does sort of the same thing that we see with the German, part of speech tagging and sentiment analysis. It works with the older version of Python as well, which I think is kind of strange. That indicates it's been around for a while. And they also have, examples of how to pull in those tools and start to analyze things. And notice how they kind of break down the words, right? And I'm not sure how you even say that, but they're identifying the words and the parts of speech. And I'm not sure what the U is all about, but I think it's kind of interesting. Maybe it indicates character sets or something of that nature. We can do sentiment analysis with this as well, so that's really helpful, so you can see if something is positive. But kind of the point of this is really to overcome these language barriers, and I think it's really fascinating. And I know we've mentioned this before earlier in this course, and I think in the other AI courses. Did you guys know that Gateway now has live translation devices that foreign speaking students can sign out of the library that will translate on the fly? So, for example, picture this. You can go to the library, sign up this gadget, take it with you to the classroom, pop in your earbuds or headphones or whatever, and the teacher's saying, homework is due tomorrow. And, and it's saying, ¿Dónde está la pluma? Or whatever, the word is in Spanish, right? Or Greek or whatever. And I think that's really cool. And that's like a for real thing that's available now today, right? Now, what a lot of people don't know is you can download apps and do the same thing on your phone. I think that is so darn cool. And it's, once again, it's like science fiction kind of coming to life. Do you guys ever watch like the old Star Trek series? And they're like, come on, they're not really talking to aliens. And then in some of the follow-up series they did, they have those little badges that they have on their shirts, like up on their chest. And those are both a communication device and the translator. So they can just kind of talk to anybody. It kind of figures out their language really quick. They probably have one hell of a chat GPT on the enterprise, right? And they can translate stuff on the fly, right? And they call it the universal translator. And isn't it strange now we have those devices available right at our own school? Like weird, right? Right. Human languages, fine. There's 7,000 of them. Can you imagine how many languages there might be out in the universe? So we get into some deep stuff here. Now they are talking here as we kind of move forward, talking about OpenAI's GPT and Google's new neural machine translation. And these are making huge inroads, by the way, and some of the more powerful tools out there. OpenAI has this pre-trained transformer. It does a really good job of translating, but it does so by the virtue of heavy, heavy training on large volumes of data, right? It uses certain type of architecture. They call it sequence architecture, which we talked about earlier, which takes the input in one language, generates the corresponding translation in the target language. It learns the patterns, linguistic structures, large scale training data is used, and supposedly it works really well, right? And I think we may have experienced that if we've used those tools. The Google uses a different type of approach, and they use basically what they call machine translation. And that they have these like score charts here. So it's kind of interesting when you start to compare to, like, for example, to European languages like Spanish, French, English, European language to European language, the accuracy level is a lot higher because let's face it, those cultures have intermingled longer, and some of the languages, like Spanish and French, I would think are kind of close to each other in some ways, more so than Chinese and English. But you notice how the Chinese and English ones, we're kind of missing some of it for sure. It uses neural networks to improve the accuracy, including deep networks. And notice it has 8 encoder and 8 decoder layers. That's a lot, right? And most of the models don't go that deep. This one uses 8 layers. So kind of like we have machine learning and deep learning. This uses deep, language translation models. And because of that, it does take a whole lot more processing. So there's more processing involved in this model, generally speaking. All right, so here they're kind of pointing out to handle rare words, it divides them into a limited set of standard subwords or word pieces, right? And I think this is kind of an interesting approach because that is, like sometimes we squeeze words together that don't necessarily belong together, right? Like for example, bedroom, right, is one word in the English language, right? But maybe it really is 2 words, bed space room, right? But we've over time, we always say bedroom together, so we squeezed it together. Doesn't mean it's the right way to do it. But they use that technique to identify that in other languages, so other languages that may have squeezed words together and then to break them apart. They're claiming that reduces translations errors by 60% compared to the phrase-based approach, which would be the previous tool. All right, getting to the home stretch here, folks. All right, it says LLMs go beyond text-based understanding by incorporating visuals, audio, and multiple languages. And this gets pretty heavy, right? Because we've been talking a lot about language, but we are forgetting about the other media formats, right? Because we do have images and audio. So like if language is written, that might be a whole lot easier for a coding language to process because it's text. And coding languages are very good at processing text because they're built with text. But what happens when I'm speaking words, and how do we translate that? right? So, and when they, so the point of this is, what do they mean by multimodal, right? And that would be to be able to extract meaning from images and audio. Okay, and this is really kind of crazy, and I'll give you an example of this because here's a goofy thing that I do. When I register my car, the first thing I do after I get the registration slip is I take a picture of it with my phone, right? Okay, why? Well, what if I lose it, right? And in the old days, I used to scan it and print extra copies, and I'd take the copies in the car, not the originals. This is me being very, very goofy. But then I started figuring out, okay, I take a picture with my phone, it uploads to my Google Photos, and then whenever I need to find it, so if I get pulled over and I'm like, shoot, I can't find the registration, I can find it in my Google Photos. I just remember when I registered the car. And then I realized that Google now has AI search technology on Google Photos. So I can type registration and a car brand or model, and it finds my registration slip in my photographs. So this is the kind of tool that we're talking about. So really, it's OCRing, right? Maybe on the fly, the content. And so if I like, so I own several Volkswagens, for example, so I can just search Volkswagen or Toyota and add the word registration, and boom, there's the info, right? So multimodal, and this is kind of the era that we're moving into. So multilingual, right? So we handle multiple languages. We have to train it on a bunch of different languages, right? And then different patterns of speech. And then, this is a process that's been going on a long time, like to basically switch from one language to another. It's not completely unusual. And in fact, the process goes back, thousands of years with all of human history, because you meet like one, group of people and another group of people. They don't speak the same language. They got to find a way to communicate, right? And eventually they figure it out. When we start to look at multimodal, then we throw in the things that I'm talking about, where we can identify the language in an image or a video or a snippet of audio and adjust to it automatically. And I think this is really interesting to try, right? And I'm tempted to do this. I'm not going to do it during the video, but and like I said, I've never tried doing translation stuff in a generative AI model, and I'm wondering why I've waited so long, actually, right? And I'm really curious, like if I fire up my chat GPT and hit the microphone and start talking to it in Greek to see what it does. Will it just respond in Greek? I'm wondering. All right. And so those of you that do dabble in other languages, try it out and tell me what happens. I'm really curious to see what happens with that. But there's a whole bunch of things that it's really useful for. And think about this. Do you ever like watch like a video on Netflix and it happens to be let's say some program or movie or whatever from a different country, and a lot of times you avoid those because like, oh look, it's from Norway, I'm not going to watch that, and then you realize, oh, I can just turn on the English captions. That's one thing, and those are probably typed in manually, right? But then they sometimes have second audio tracks, right, where somebody took the time to record all the dialogue in English or whatever language. And I think that's just crazy that people would take all that time to do that. And now what's happening is they're starting to use AI models to do that work automatically. I don't know how good that is for like, a movie or something. I would think it's better to use humans still, but that's possible. We're in the era now where that happens. Another thing that's very interesting, and I've been experimenting with this, we have a requirement here at Gateway that over the next year or so, we're supposed to have all of our course content within Brightspace so that it is fully meets accessibility guidelines, right? Because we're a public entity, right? We're a school, we're paid for by the public, basically part of the government, really, if you want to think of it that way. And we cannot deny people based upon whatever disability they have or what language they speak or whatever, if they're blind or deaf or cognitively disabled. So we have to make all of our websites accessible. And that includes, like, if I took images that we see like in this slideshow, that and it's an image, right? That has to either have a alt text added to it where it would completely describe every aspect of the image, or oh, thank you, Laura, for saying that. Oh, interesting. Very interesting. Yeah. So, yeah, it's kind of what I thought it would do. It would automatically detect the language and then respond appropriately. But going back to this accessibility issue, like, for example, if I had an image of a spreadsheet as an example, and there are a bunch of words in the spreadsheet, the requirement going into the future is that I have that all the text in the image has to be converted to text and added as background text to the image. So if somebody with a screen reader was looking at it, they could still understand the image. Isn't that weird? Right. Here's what's really interesting. And I've experimented with this where I have images like that, and I've taken them, and I've tried this both with ChatGPT and Gemini, by the way. I take the image and I say, I need to make this image accessible, or I need you to OCR this image for me. OCR is optical character recognition. So it turns the image into text, and then we can add it so it becomes accessible, inside of Brightspace. It's this whole process, right? We're moving into that mode. But can you imagine, right, like that maybe videos can be automatically captioned? Really interestingly, that is exactly what YouTube does to my videos. Like the one I'm recording right now, it's going to listen to my voice in the video and convert it to closed caption. One of the reasons I use YouTube to publish my videos is because it does such a good job of it, even with really weird technical terms and computer code. It picks up on it and converts it into text. Otherwise, you know what the process is? I'm supposed to record a video, turn it over to our people on campus. They would manually type every word I speak, right? Can you imagine that? Embed it into the video and then give me the video back so I can publish it. Which do you think is faster? Right. And so I lean really heavily. Now, I'm going to suspect that those people that do that work also use the same tools. Right? They might use YouTube also to do it, or some other engine. But we are in that era right now. And this is kind of interesting, right? Like if you guys use like chat gpt or like notebook lm or something like that, you can take like a document in there, throw it in there, it analyzes the document, and then you can use the little chat window to ask questions about it based on the information you just gave it. Well, now you can do that with images and video. Crazy powerful stuff. So this is the multimodal thing that we're moving into. There is this multilingual, or what they call MT5, which is trained. So it goes text to text. So it's a transformer thing. And they have it pre-trained on this MC4 corpus, right? And notice where that goes. If you hover over the link, that goes to TensorFlow, and it covers 101 different languages. Pretty impressive. If you want to try it out, you can go to Hugging Face here and pull that up, and it probably will hopefully work for you. I have found that a lot of these Hugging Face examples that they show here often don't still work in the browser, so I don't think it might work as easily. Notice that it does give you the tip here. Try executing the code above in Colab, which is the Google free Python online notebook. Have you guys tried that yet? Anybody play with that one? Yeah. And what I found about Colab, and you can look this up, is through Gateway. Gateway doesn't pay for it apparently, so I can't run Google Colab through Gateway. But if I use my personal Gmail account, it is accessible. And that's kind of like a Jupyter notebook, but all online and inside of Google. So kind of interesting. So they're suggesting that you try it there. All right, the remainder of the slides here do cover lab work. And basically what this is going to do here is this would be your guide, basically, if you want to be guided through working with the Python files that are included in this unit. So remember, I gave you a student file, which is the starter version, which has instructions embedded in it. And I also gave you the solution file. And if you guys notice here, they're giving you a screenshot of Streamlit here. So if you wanted, you could do this work inside of Streamlit, and you can feed the code into that platform if you want, if you were that kind of ambitious. So that's one way that you can do it. And you know, they talk about looking at, you know, the week 10 slides, you know, if you will. But for the Python files included in this unit, we're basically going to use TextBlob to do it. And then they will give you an approach here. They're giving you an example for German, right? This is DE, right? And okay, there you go. There's your language prefixes right there, folks. And notice how they have, like Chinese, unfortunately, has multiple ones, but a lot of the main languages are listed there. And of course, they don't have Greek, but hey, whatever. It's okay. My feelings are not hurt, right? But they give you all these two-letter extensions if you want to try different languages. And how you make the app is really kind of up to you. I mean, really, the file that's provided is a straight Python file, so I hope that you work with it natively. And then you can find snippets of any of these languages out there if you wish, and then bring the language snippets in and do some translation and have fun with it, right? And see what it does. I think it's kind of interesting that it's not that hard to implement. You know, and I say that without having tried this yet with TextBlob. But, you know, sometimes there's challenges with the libraries, but, you know, there usually is a way to make it work. And of course, AI usage is okay to help you out. They give you some examples here. They ask you to run the Python program from the command prompt. You guys all know better than that, right? You don't have to run it from the command prompt. You can run it inside of an IDE. So like, even if you use Spider, you know, if you still have Spider available, and just run it in the console, right? So you don't have to go to a command prompt. If you use a VSC, we ran into that issue with the chatbot where it wanted me to type on top, and I just wasn't even seeing it because I'm not used to that, you know, but it's possible inside of there as well. Here's some additional tasks if you want to try them, right? So you can experiment with this all you want. This is basically to help guide you through working with those files. All right, a couple of reflection questions here at the end, right? Now you can answer these on your own. And then once again, the bibliography here, I don't know how many of these links are still valid, but at least it shows where all the material came from. And thank you, Intel, for putting this all together. And this lecture video ends here.